Hello, friends. Welcome to Science Talk. I'm your host, Jim Massa. I want to discuss with you in this video something we've been hearing a lot of lately, that a lot of the projections are turning out to be underestimations. In this case, uncertainties about the ice sheet could mean that the sea level will rise more than predicted or projected. Sea level could rise higher than current estimates by 2100 if climate change is unchallenged, according to a new assessment. This is a report published in the journal One Earth. The authors state that understanding the way strong global heating affects the polar ice sheet will be crucial to projecting sea level rise over the next century. However, uncertainties remain, and current knowledge about ice sheets suggests sea level rise under continued strong warming could be higher than the IPCC, Intergovernmental Panel on Climate Change, likely range by 2100. Well, there's a shocker. The IPCC underestimating? Geez, who would have thunk? These authors also suggest ways that scientists can make projections more certain by improving our understanding of ice sheet dynamics, such as how they interact with warming oceans, how they fracture and break apart. That is an extremely fair point. And definitely I agree with that. We definitely need research into those subject matters outlined right there. They're totally correct on that. So the lead author was Professor Martin Seigert from the Grantham Institute of Climate Change Environment at Imperial College in London. Greenhouse gas emissions are still on the rise, and strong heating of more than 4°C by 2100 is well within the realm of the possible if emissions continue unabated. Someone's saying 4°C, not the 3°C. And the 4°C itself might be an underestimation. It might more likely be in the 5 to 7°C realm. I saw reports and modeling indicating 7 to 9°C by 2100. As you keep adding the CO2, you exponentiate the rate of melt, the rate of temperature increase, and let's toss in, because it's directly related to the rate of temperature increase, the rate of permafrost thawing. Currently, hundreds of millions of people live in regions susceptible to coastal flooding, and the likelihood of even worse flooding will significantly increase with severe sea level rise. The sea level rise we have already faced has been somewhat mitigated by flood barriers and other measures, but we are unprepared for higher rates of rise that could overwhelm these measures. If we don't do more to avert dangerous global heating, we may reach a point where we can no longer protect people. This is the authors. This is a statement by the authors of this study. The team reviewed current models of the effect of warming on ice sheets that the IPCC's 2019 report on sea level rise relies on. For a strong heating scenario of more than 4°C of temperature rise by 2100, the report gave a likely, in quotes, range for sea level rise between 0.61 and 1.10 meters above 1950 levels. So in other words, anywhere from 60 to 110 centimeters. Okay. Approximately 30 centimeters is a foot. Okay. So we're looking at basically anywhere from 2 to 4 foot increase in sea level rise. That's in 80 years, folks. Nothing to trifle at. However, the team's analysis showed that ice sheet models do not include sufficient detail on key processes that may lead to significant mass loss under strong warming, meaning sea level rise above the IPCC's likely range is far more possible than below it. So the IPCC is saying, 60 to 110 centimeters, 2 to 4 feet, and these guys are saying, underestimation. Co-author John Englander, who is the president and founder of the Rising Seas Institute, states sea level rise will be one of the most challenging issues faced by society in the coming decades. We need to recognize that we cannot stand by and wait for clarity about actual sea level rise to begin planning for it. Waiting for better confidence in predictions is not a reason to delay building a margin of safety, for example, into building code, zoning, recognizing the inevitability of sea level rise and its catastrophic implications. And don't forget, it's not just the coastal areas that will, see the sea level rise and remove land from capable of, putting human habitation on. But if you have, a river drainage system like the Mississippi, the Amazon, the sea level rise is going to go flowing right up those things, and it will get into the aquifers. So now you're putting salt water into the aquifers. You ruin the aquifers. You're going to then, you're going to ruin the crops, so they won't be able to grow in salt water. And then you make all that aquifer non-drinkable water. So there's a lot more to this that can happen. So people say, well, yeah, you're adding ice, so the salinity will be reduced. Yeah, yes, it will be. But even if you reduce the salinity by a little bit, the Atlantic is typically on average 33.5 to 34 or so on average over entire North and South Atlantic taken together. Even you reduce it to, I'll just throw out, it won't, but let's just say reduce it to 29 parts per thousand. It won't. It won't reduce that much. You still can't drink 29 parts per thousand water. You still can't. The salinity humans can tolerate up to is 4 parts per thousand. So this has implications. There are 2 main ways sea level can rise substantially at a global level. Throughout the 20th century, rise has been dominated by thermal expansion, because we're heating the water, right? So when you add heat to the system, you add kinetic energy to the molecule. The molecules move apart from each other, and thereby you get the expansion of the volume of the water. However, in the 21st century, the second mechanism has become dominant: the addition of water from melting ice sheets and glaciers. So we have 2 methods here: thermal expansion, adding meltwater. Now, sea level rise due to thermal expansion was fairly straightforward to make projections on. You basically do a simple relationship. What's the temperature? What's the expansion? You can go from there. It's a straightforward calculation. You can then calculate that over the entire surface area of the entire ocean, all the ocean, planet, and make a fairly reasonable projection. But ice sheets and glaciers respond to rising temperatures in a complex, interconnected way that makes any projections more difficult. Researchers looking ahead to the next century of climate change and its increasing impact on human society, nature, and the environment often look back at previous episodes of natural climate change for clues as to how various Earth systems will react. And that's something I have said many times. If you want to get an idea of what might transpire in the future, look at the past. At the end of the last ice age, there is evidence that ice sheets responded to warming by rapidly losing mass at rates that at times were higher than currently observed, leading to several meters of sea level rise per century. The team says this means current projections of sea level rise may be underestimates, as the ice sheets may lose mass faster over the coming century than our current models predict. Now, what are some of the ways in which you can lose the mass faster? So we got the obvious heating from above from the sun. The air is warmer. That will facilitate melting of the ice. You're warming the ocean. So now we have warm oceanic water going underneath the ice, melting it from below. You have riverine inputs. Rivers are inputting water above freezing. That especially affects the sea ice. Okay, here they're talking more about the land ice, but still, let's say you have meltwater running through a glacier, land glacier. And we've seen this in Greenland, by the way, that the water is warmer, and so it's warmer, so it's really cutting through the ice sheets that are in Greenland. So, meltwater, river water, especially if you're looking at alpine glaciers, the Himalayas, the third pole. So you have all these mechanisms to melt the ice, and now the interaction, and where does especially like looking at the land ice that juts out into the sea. That's what I was referring to about warm water from underneath. Think Antarctica. Where does it weaken the ice? Where are the fracture points, the fracture planes that are created from the warm oceanic water underneath? As they rightly point out, that's areas that need to be researched. To improve models and predictions, the authors identify key areas of research that needed to fill in our gaps in knowledge. These include better mapping of the ground beneath glaciers and ice sheets, collection of data at the margin where glaciers meet the ocean, and improved coupling of models of the atmosphere, oceans, and ice sheets. Now, the point about the margin. Now, are they talking about where the edge of the ice, is cantilevered out past the grounding line? Or are they talking about the grounding line, or both? Now, the grounding line is basically where the ice is sitting on the land. Past the grounding line, it juts out and you have water underneath it. And so when I was referring to earlier about warm water coming underneath, that's what I was talking about. So it will melt the ice from underneath. How does that affect that portion of the ice sheet above? How does it weaken it? How does it crack? Where does it crack? And of course, once it cracks and breaks away, then that kind of frees up the ice behind it to start resuming its slide past the grounding line. So these are excellent suggestions that they bring forth. While the network of existing observations of ice sheet dynamics already gives scientists a very strong warming signal, causes for concern, the authors say these improvements could lead to a next-generation early warning system focused on signals of rapid change in sea level, such as increases in ocean water temperature along the margins of ice sheets, kind of what I was just alluding to. Professor Siegert says, we already have a good start on an early warning system for dangerous sea level rise with satellites, airborne platforms, robotic devices, field investigators, expert knowledge. While this network is growing and getting stronger, it does have major weaknesses at ice sheet boundaries that require urgent action. We need to develop an array of robotic devices in key parts of Antarctica and Greenland that are most vulnerable and capable of rapid sea level rise in the future. So, basically, what they're saying is that the IPCC, yet again, has underestimated things. There's no shocker there. And they then identify areas of further research. And the areas they identify for further research are extremely excellent suggestion, very pertinent, and I'm in total agreement with. Because we can get a better understanding of the dynamics of the mechanisms that will improve our modeling and from that our projections. But you've got thermal expansion from warming the oceans. You've got ice melt adding water directly to the ocean level. The thermal expansion is still happening. Right? The warming of the ocean is still happening. So now you've got two mechanisms at work here. Two mechanisms influencing sea level rise. So 2 to 4 feet by 2100 is a lot, and that's an underestimation. Probably going to be a lot more, especially if you look at the models the same 5 to 7 is most likely how much warming will occur by 2100 if humans don't do anything. Some are saying 7 to 9. Either way, not good. So now the idea of like second generation early warning system, I don't know if we have room, if we have time to get that in place the way things are going. But they're doing important work, and they've outlined where the knowledge is lacking. So let's get to work on those. Let's find out what's happening with those concerns. So Antarctic's ice loss, right? It's going to add, and this is going to be in my next video. Is I'm going to be talking about the Antarctic ice loss specifically. This video is more of a generalization. So my next video, I will discuss what's happening with Antarctica. So thank you for your time. Hello, folks. This is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.